An electric field is a region where a charge experiences a force. We can visualize the electric field around positive Q by placing small positive point charges into the field and displaying the force vector acting on each. Click on the region around Q to observe the force on a small positive point charge. Note that the small point charges are considered too small to distort the field due to Q. Electric field lines allow us to visualize electric field. A field line shows the direction along which a free positive test charge would move if it were placed in the field. Use the interactive model above to observe the electric field lines when the charge is increased. What is the difference between the electric field due to a positive and negative charge? Answer: the directions of the field lines are opposite. What is the effect of increasing the charge on the field lines? Answer: increasing the charge increases the number of field lines and squeezes them closer together. The electric field strength E at a point is defined as the force acting on a unit positive charge at that point. Electric field E equals force over charge equals F over Q. Electric field E is a vector quantity. It has both magnitude and direction. Unit of electric field is newtons per coulomb or volts per meter. Click on the derivation button to deduce the expression for the electric field due to a point charge Q. Click the point charge positive Q to observe how the electric field strength E at a point is defined as the force acting on a unit positive charge at that point. Electric field E equals force over charge equals F over Q. Electric field E is a vector quantity. It has both magnitude and direction. Unit of electric field is newtons per coulomb or volts per meter. Click on the derivation button to deduce the expression for the electric field due to a point charge Q. Click the point charge positive Q to observe how the electric field E varies with the distance r from the point charge. Click the charge negative Q to observe how the electric field E varies with the distance r from the point charge. Summary: electric field strength E at a point in an electric field is the force on a unit positive charge at that point. E equals force over charge. Electric field strength is a vector quantity. Its direction is the direction of the force on a positive charge. Unit of electric field E is newtons per coulomb or volts per meter. The electric field E at a point distance r from a point charge Q is E equals Q over 4 pi epsilon naught r square. In this interactive model, you can see the electric field pattern between a positive and negative point charge. Use the sliders to select the 9 different combinations of charges and observe the electric field patterns. click the Next button. In this interactive model, you can see the electric field pattern between two positive point charges. Use the sliders to select the 4 different combinations of charge and observe the electric field pattern. Two-point charges positive Q and negative Q are at a fixed distance, r apart. What is the resultant electric field at the midpoint x between the charges in terms of Q, r and epsilon naught? Click the charge positive Q to see the expression for the electric field E1 at the point x due to the charge positive Q. Then click on the charge negative Q to observe the electric field E2 at the point x due to the charge. Notice that E1 and E2 are both in the same direction, and their magnitudes are used in the calculation. The distance between the two equal point charges positive Q is r and P is the midpoint between the two charges. What is the electric field at P? Click on each of the point charges and observe the electric field at P due to each of the charges. Hence, deduce the resultant electric field at P due to the charges. Two-point charges Q1 and Q2 are separated by a distance r. Find the direction of the resultant electric field vector E at the point P, distance r from each of the charges. If Q1 equals Q2 equals 1c, click E1, electric field due to Q1 and E2, electric field due to Q2 to check your answer. Now try to deduce the direction of the resultant electric field vector at the point P for other values of the charge Q2. The charge Q1 remains as 1 coulomb. Move the slider to choose different values for Q2. Evaluation. Two-point charges positive Q and negative Q are fixed at equal distances from the point P as shown. Click on the arrow representing the direction of the electric field E1 at the point P due to the positive charge positive Q. Then click the arrow representing the direction of the electric field E2 at the point P due to the charge negative Q. Now click on the point P to observe the direction of the resultant electric field vector E at the point P. Summary. To find the resultant electric field due to a number of charges, use vector addition.